Hello, in today's video I will be talking about hexadecimal and how to convert them. But where can we find examples of hexadecimals? So in this lab, and the whole reason of this lab just to show you, I will show you how we can do that through the command prompt on the PCs, the MAC addresses and the IP version 6 addresses, and using Arp and Ipconfig commands. Now, what Arp stands for? Address Resolution Protocol. When you try to ping an IP address on your local network, just for example, let us say 192.168.1.1, your system has to turn the IP address 192.168.1.1 into a MAC address. Because it is a broadcast packet, it is sent to a special MAC address that causes all machines on the network to receive it. ARP is a layer 2. The reason being is that a broadcast is sent on layer 2, which is the data link layer on the OSI model, and ARP will normally not traverse to layer 3, which is layer 3 on the OSI model, the network layer. However, it can provide extra features to the layer 3 protocol. Now if you ask why ARP is needed, basically ARP is a function of the IP layer of the TCP IP protocol stack. It's necessary to translate a host software address, which is the IP address, to a hardware address, which is the MAC address. Typically, a host uses ARP to determine the hardware address of another host. Now, we have this topology. We have the two PCs here are connected to the switch. Both PCs are configured with an IP address as showing here in this diagram. We have PCA with this IP address, and also we have PCB with this IP address here. Now this is how I can view the MAC address on the two PCs. We have the MAC address. The whole reason or the purpose of this lab or this video just to show you examples of hexadecimals numbers, which is I'll show you the MAC addresses plus the IP version 6 addresses. I will go to the config tab. This is PCA, click on it, the config tab here, the second one on the left, and from there I will click on the fast Ethernet 0. Here on this is the packet tracer. Even on the real world, when you connect a switch to a PC, on the PC we have the NIC, network interface card. It's connected on the fast Ethernet 0 to the switch, which here in this example, which is the port fast Ethernet 01. Now on the PC I clicked on the config tab, and here I'll click on the fast Ethernet 0. Now I gave this PC this MAC address to illustrate this lab. As you can see here, this is the MAC address and this is the IP address of 8.8.8.1 and with the subnet mask of 255.255.255.0, or you will say /24 after you mention the IP address, which is we have this IP address here in decimal and the MAC address in hexadecimal. Now, this is a way. This is in a packet tracer to show you the MAC address. Another way, if you click on the desktop tab here, click here, and from the command prompt icon, I will type this command, which is ipconfig, one word, and then hit enter. I'll expand this a little bit. As you can see here, this is the IP address of this PC, but to view the MAC address of this PC, we type another command. Here with ipconfig, it will just show you the IP address of the PC statically configured here on this PC with the subnet mask. And also, if you notice, the link local IP version 6 address is showing here. This is also hexadecimal. This IP address version 6 is written in hexadecimal. The IP version 4 address is written in decimal. The other command, one word, ipconfig space / then all, and then hit enter. Here we want to study this a little bit and have a look at it, the results. As you can see, this is the physical address of PCA of 00E0.4 A's followed by 4 A's. This is how I did it, just to illustrate this slab, just for PCA with A's in the MAC address. And as you can see here, for the link local IP version 6 address, it starts with FE80, and the IP address which I configured statically of this machine of 8.8.8.1 with a subnet mask of 24-bit 255.255.255.0. Here we can call it, as you can see here, physical address, which another name of the MAC address, and there are other names actually for the MAC, and also showing us the IP address as I showed you, and the IP address here is written in decimal. This here is the physical address written, as I said, in hexadecimal. This is a 12 hex number. Each hex is 4 binary bits. Here also we can see the IP version 6 of this PC. This is a hexadecimal number. I will do the same thing on PCB. I'll close this or just move to PCB, and here I click on the config tab, and also on the fast Ethernet I click here, and as you can see, for the MAC address, which is written in hexadecimal of 00E0 followed by 4 B's and with a dot, and then followed by another 4 B's, and this is the statically configured IP version 4 address of 8.8.8.2 with a /24 subnet mask of 255.255.255.0. This is a way how we can read the IP address of the machine using packet tracer. Another way, just a click on the desktop tab on the top here, and under the command prompt icon, click in here, and then I'll type the IP config, one word, and then hit enter. It is gonna show us the IP version 4 address plus the IP version 6 address, which is written in hexadecimal, and IP version 4 is written in decimal with the subnet mask. We want to view now the MAC address or the physical address of this machine with the command of ipconfig space / all, and then hit enter, and it will show us here the physical address or the MAC address of this machine with the IP version 6 address also of this machine, and the IP version 4 of 8.8.8.2 with the subnet mask of 255.255.255.0. If you look at the MAC address, the first half on the left here, the first 6 hex here, this is the OUI, which stands for Organization Unique Identifier, and the second half on the right is a unique number for the device. Now MAC, which stands for Media Access Control, is a unique identifier assigned to a network interface controller NIC for use as a network address in communications within a network segment. This use is common in most IEEE 802 networking technologies, including Ethernet, Wi-Fi, and Bluetooth. Now, let's move to the fun stuff. If I ask this, what is ARP and why is it used? ARP is short for Address Resolution Protocol, a network layer protocol used to convert an IP address into a physical address such as an Ethernet address. There is also reverse ARP, RARP, which can be used by a host to discover its IP address. Now, on PCA, if I type this command on command prompt, PCA here, it's just a PC standing by itself. It knows only about its IP address, nothing more. If I type this command, arp space dash A, and then hit enter, and it is showing us no ARP entries found. This is telling us there is no IP addresses are combined with MAC addresses in this network yet. This PC does not know any other devices in this simple network. Now on PCA, if I ping PCB with this command, ping 8.8.8.2, and then hit enter, we are sending a ping to PCB, and we received a reply, as you can see, from PCB with the IP address of 8.8.8. Now this is PC knows about another device in the network with this IP address, and it is asking who has this IP address, and then PCB will reply back. Now when I type the command again, arp space dash A, and then hit enter, as you can see, we have the IP address, the decimal IP address, IP version 4 of PCB of 8.8.8.2 with the physical address, as you can see here on the window. I did the ping on PCA. It sent the ping to PCB and received back this IP address, and even when I typed ARP A on PCA, it gave us back the IP address of PCB with the MAC address. But on PCB we did not say ping anywhere. But if I type this command, ARP space dash A, hit enter, it's showing us the IP address of PCA of 8.8.8.1 with the physical address, as you can see here, but we did not send a ping from PCB. This doesn't matter because PCA, it started or initiated a communication through the switch to PCB. The switch received the ping from PCA. We have this here only two PCs connected to the switch. So the switch, when received the ping on this port of Fast Ethernet 01, it switched it directly to PCB. Now we have the packets are traveling between PCB and PCA, and both PCs know about each other's IP addresses plus the MAC addresses when I ran the command ARP. So now on the switch, I will simply type this command, but I will type this command of enable and then show MAC address table. We want to know about the MAC address table of the devices connected to the switch, and then hit enter. It's showing us that the two PCs are within VLAN 1, which I'll explain more or furthermore in future videos, and we have the PCA connected to the switch on the port of Fast Ethernet 01 with this MAC address, and also PCB on the other port of Fast Ethernet 02 with this MAC address. So this, now if we go to PCB and change the MAC address, and under config Fast Ethernet 0, here I will just do a little bit change, b1.b1.b1, and that's it. And then go back to PCA and type the command arp space dash A, and then hit dash A, and then hit enter, and it's showing us that we change because we ran the ping that this PC is now with this IP with this MAC address of 00E0 B1 just like I changed it a second ago. Now on PC, on the switch, if I run the command again with the upper arrow on your keyboard and then hit enter, and it's showing us the old MAC address of PCB and plus the new one. Both are bringing the information about the MAC address from the same port or the same interface on Fast Ethernet 0202. But this will not last forever. This table will change because there is a period of time that the table will be updated. Now the whole reason, as I said, of this lab, just to show you that we have the hexadecimal, the MAC address, and also the IP version 6 are written in hexadecimal, plus the IP version 4, the IP addresses of the two PCs, which are written in decimal. Now it's time to talk about hexadecimal, the numbering system. We have the decimal, which consists of 10 numbers, and it is base 10, and we write the numbers like this from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have also the binary, which consists of two numbers, and it is base 2, and we have two values, 0 and 1. When the bit is on, it takes the value of a 1, and when it is off, it takes the value of a 0. Now we have the hexadecimal, which consists of 16 numbers, and it is base 16. We write them just similar to the decimal from 0 to 9, and the rest, 10, 11, 12, 13, 14, and 15, we represent them as letters, as A, B, C, D, E, and F. Now, in this slide here, the decimal number 10 is an A in hexadecimal, 11 is a B, and 12 is a C, 13 is a D, 14 is an E, and number 15 is an F in hexadecimal. So if you look at this table here, as you can see, the decimal numbers from 0 to 9 is similar to hexadecimal numbers from 0 to 9. But when we convert them to binary, because we said each hex is a 4-bit binary number. So the 0, it takes this numbers here in binaries, and if we look at another example, number 6 in decimal is this in hexadecimal, and when we write it to binary, we write them like 0110. As I said, each hex is 4 binary bits. For example, the decimal number 0, when we want to write it in hexadecimal, its value in binary as 0000, and the F in hexadecimal, in binary, this is its value. Now, as I said, each hex consists of 4 bits. The first bit on the right, its value is a 1. The second bit, its value is a 2. The third bit, its value is a 4. And the fourth bit, its value is an 8. Now, if we have this example here, if we want to convert the decimal number 224 to binary, then to hex. Now, in binary, we write it like this, because this is a decimal number, and it is an octet in an IP address, so it is an 8-bit. But in hexadecimal, each hex is 4 bits, so we split it into 2, the fourth on the right and another fourth on the left, the other fourth, sorry. Now, now let's take the hex on the left. The first bit is turned off, so its value is a 0. The second bit is turned on, and its value is a 2. The third bit is turned on, and its value is a 4. So 2 plus 4 is a 6, plus the 8, which is the fourth bit's value, is an 8, and it's equal to 14. And the hex on the right, it's all turned off, so its value is a 0. In hexadecimal, we write the 14 as an E, and the 0 as a 0. So the decimal number 224 is, we write it in binary like this, and in hexadecimal as an E0. Another example, if we want to convert the decimal number 248 to binary, then to hex. So the 248 in binary, we write it like this. It's an octet which consists of 8 binary bits, but in hex, we split this octet into 2, 4 bits in 4 bits each. So the hex on the left, because it's turned on, and the value, if we 1 plus 2 plus 4 plus 8 is equal to 15, and the hex on the right, the fourth bit is turned on and its value is an 8, so we write it 8. So in X, the 15 is equal to F, and the 8 is 8. So the decimal number 248 is 1110, followed by 4 zeros, and in hex, we write it as an F8. Now, we have, if we want to convert an IP address, like this IP address of 192.168.1.1, so in decimal, we write it like this. And when we convert it into binary, this is how we do it, as I showed you in a previous videos. Please go back to the videos and you will learn from it how to convert decimal to binary. And in hexadecimal, so we will take the first octet on the left, which is 192. When we convert it to binary, it takes this, and we split this to 4-bit each, because each hex is 4-bit. So the left bit, or the bit on the left, the hex on the left, we have the fourth and the third are turned on, and both values equal to 12. So we write the 12 as a C, the 0 as a 0, the 10 is an A, 8 as an A, either in hex or in decimal. The 0 is a 0, the 1 is a 1, and the 0 is a 0, and here 1 is a 1. And another example, if we want to convert this IP address in hexadecimal, in decimal, this is how we write it, like the normal way. In binary, this is how we convert it, and in hexadecimal, this is how we will do it. Because the values of the bits here, for each hex, the one on the left, 1010, the fourth bit is turned on, its value is 8, the second bit is turned on, its value is a 4, is a 2, so 2 plus 8 is a 10, and so on and so forth. And now the A in hex, the 10 is in hex is an A, and the 12 is a C, 1 is a 1, the 15 takes an F in hexadecimal, the 0 is a 0, and the 10 is an 8, and 12 is a C, and 8 is